Hello, welcome to Origins. I'm Ray Heipel. It's an honor to be your host today. During this program, we showcase interesting guests who present evidence from science, along with other important facts, validating the truth of creation and the accuracy of the Bible. Our guest today, Dr. Paul Nelson, studied evolutionary theory and the philosophy of science at the University of Chicago. He's currently a senior fellow of the Discovery Institute and adjunct professor in science and religion at Biola University. Paul has been involved in the intelligent design debate internationally for more than 2 decades. Welcome, Paul.
Hey, it's great to be here.
Looks like we're talking about design in marine life. How do we see that?
Well, think about it this way. Suppose I took you on a cruise to Alaska in the winter and you slipped off the boat in your shorts into water just above freezing. You would last about 15 minutes, right?
I don't think I would even last that long.
Well, here's the problem. The heat in your body is going to flow naturally out into that cold water. Humans exposed in those circumstances don't live very long at all.
We're not designed to live in that
We're
kind
not
of
designed.
environment.
Whales and dolphins flourish because they have a protecting, insulating layer of blubber. So here's the question. What would it take for a mammal to live in salt water 24/7, 365?
So, and a mammal being warm-blooded, right?
Warm-blooded, right.
That's the key thing.
That's
okay.
the key thing. There are other features that characterize mammals, but let's take a creature in our imagination that lives entirely on land and try to get it to live entirely in water and do all its business there. So let me just take you through some of what you'd have to do to be able to manage that. You would need to change your way of getting around. Just navigating, through that aqueous environment. You'd have to change the way that you feed, how you eat and drink. For instance, whales and dolphins ingest a lot of salt water. That amount of salt water would make you and me very sick, but they do it without a problem. Sleeping. How do you sleep without drowning, right? Fall asleep, you've got to keep coming back to the surface to get oxygen. You've got to engineer that process. How are you going to learn and play, which are closely connected for all mammalian species? How about this? Mating. Now, we'll talk about that in a little detail in just a moment. That's going to be a problem. You want to keep your species going, you're going to have to find a female or a male, do what comes naturally, so to speak. That's going to be a challenge. Giving birth and raising young. Imagine you have to give birth in water and your offspring is going to come out not near oxygen, but surrounded by water. You're going to have to be able to get it up to the surface to breathe and so forth, migrating and evading predators and on and on. All of this is going to have to be modified for you to survive successfully in salt water all the time. So let's talk about mating. All right, everyone's interested in that. Everybody in the audience, every male, knows where his testicles normally reside. Right? They're outside his abdomen. And there's an important functional reason for that. The normal formation of sperm requires a temperature lower than that of the rest of the body.
Is that true for all mammals?
That's true for all mammals. Sperm formation in mammals requires a lower temperature to be successful. So for us, for humans, our testicles are outside our abdomen. But let's take a look at these guys. Okay? Nice and smooth back here, okay? There are no external testes on these dolphins. Yet we know they're mammals. We know those organs are there. They're entirely inside their body cavity, entirely inside their abdomen. Now that creates a problem. When a dolphin is swimming, it generates a lot of heat. The muscles it uses to swim raise its core body temperature. It's got to be able to cool down its testes for sperm production. Here's how they do it. It's really amazing. They have what amounts to a refrigeration system. What they do is they take blood from here that's cool, from the dorsal fin and from their tail, and circulate it right up against the arteries that supply that structure, the testes. So if we zoom in on some of these structures, you can see here that the cold venous blood is running right up against the warm arterial blood, and thermodynamics kicks in, and the heat flows from here over to there, lowers the temperature of the arterial blood that's supplying the testes. We've got a video that helps us see this in more detail from the film Living Waters.
As a male humpback swims, it generates heat, raising its body temperature. To prevent sterility, the whale relies on a refrigeration mechanism designed into its circulatory system. In the non-insulated regions of the dorsal fin and tail, blood is cooled and then transported through a network of veins to the whale's abdomen. Here, beneath a layer of muscles, a web of veins and arteries surround the testes. They are arranged so blood flows in alternate directions, and heat from the warm arteries radiates to the cooler veins. This transfer lowers the temperature of the blood to a safe level before it is channeled to the reproductive organs.
It's a remarkable solution to that problem. It's beautiful. It's anatomically complex. It involves what is called, borrowing from the Latin, a miraculous web of arteries and veins. But can you explain it by some smooth, gradualistic, textbook scenario, little change, fixation? No, it doesn't fit the Darwinian model. In my opinion, you're looking at just a suite of characters that had to have been integrated from the get-go. I mean, it's a non-gradualistic type of change. So the cooling system makes sense because you have internalized reproductive glands. The internalized reproductive glands, however, are a no-go unless you've got the cooling system. You can't explain the emergence of one without the other.
That's just one feature of the many that would have to be modified to live in salt water all the time. So here's just a partial list of the things that would have to be changed. If you take a terrestrial mammal, that species, and move it into an aqueous environment, everything has got to be modified.
Every one of these things that formerly land creature now has to be able to do to live in the water.
That's right. And the list goes on. In fact, we could spend a week discussing everything that has to be changed. The ear bones, the breathing system. They have their nostrils on the top of their head, and every breath they take is voluntary. You're not thinking about how you're breathing right now, nor am I. But when they open their blowhole, it's under the control of voluntary muscles. So when they come to the surface and open that to let in oxygen, they're doing so voluntarily. Let yourself think about this like an engineer, and you realize I'm going to have to modify absolutely everything about these creatures. In fact, Hans Thewissen, who is probably the world's leading evolutionist on this question, put it this way in a book that he published a couple of years ago. He said, what would it take to build a whale? Well, you think, how would I describe this to a general audience? He says, imagine you have a submarine and the Batmobile, and you're going to go from the Batmobile, there it is, the Dark Knight version, okay, to something like this. There's the Yellow Submarine, a real Yellow Submarine. But you're going to start here. This is your starting point. You've got to modify this system to give you that system. Tuissen says that's going to be a problem because everything that works for the Batmobile really isn't going to work for the Yellow Submarine. You're going to have to change it all. He goes on, if you have to have a working system at the end of every day, that's going to really challenge an engineer because in evolution, every step along a pathway of change has got to be a functional species. It's got to be a functional organism. He said that just shows you really how hard this problem is going to be to solve. And he puts it this way, how remarkable the transition was from land-dwelling mammal to fully aquatic mammal.
I like what he says above that. It would be an impossible job. It's impossible. Well, I guess that makes it pretty remarkable.
Well, that's what he said. Yeah, impossible and remarkable, right. The thing is, he thinks this happened by an undirected process. In other words, during the construction, to go back to our original metaphor that Tuissen uses, during the construction of these guys, mistakes are made in the assembly line, and somehow those mistakes accumulate and you end up over here. So that's what's really amazing about the way that he looks at the problem.
That's right, because it can't be designed, it can't be engineers trying their best to make that work. That's intelligence.
Right.
It has to be mistakes. Oh, the tire didn't get inflated properly, or the brake lining's worn or something, and somehow that turns it into a submarine?
That's right. You're going to have a series of errors in millions and billions of Batmobiles that are going to bring you over here. Now, we look at this and we find it implausible, and the question is why? Well, we find it implausible because we know just how hard it is to build something like this compared to something like this, and the engineering required to have a functional system at all. So let's look now at the biological story in a little more detail, because when we go into the details, we find the problems with the evolutionary account. They're all going to start, all evolutionary scenarios will start with mutations in DNA. Because according to standard theory, mutations in DNA change the manufacturing process. Well, for something like mammals, the developmental pathways, and then that changes the final outcome. So if you want to modify the anatomy of a land-dwelling form, change, for instance, the forelimb from a hoof structure to a paddle, you're going to have to modify the developmental process that builds that structure. So all the changes that we're going to make are going to start with undirected mistakes or mutations in DNA.
Because DNA is what tells each cell what to do, right? It's the DNA that's telling those cells you're going to be a hoof rather than a flipper or a hand.
Exactly. DNA, according to standard theory, will provide the instructions for building mammals. So Batmobile to submarine, normally for humans we'd say we're going to need intelligence for that. But the explanatory toolkit of evolutionary biology eliminates this kind of cause. This is all you're allowed to use.
What would be just an example of a natural cause?
A mutation. Let's say a high energy particle hits DNA and changes the base pair, so the gene produces a different protein. That's a natural cause. As far as we know, there's no intelligence behind it.
So just a random change that happened outside the organism. It wasn't directing it.
Right. It's an undirected, random event, random occurrence. And there's no engineering allowed. You've got to do it entirely with blind forces, and you don't have very much time. So here is our evolutionary scenario. This is standard geology. This shows a evolutionary tree, if you will, of the forms that were supposedly ancestral to whales. We have an 8 million year window to do all of this. In other words, if you look at the geological time scale here, the time from the appearance in the fossil record of this form and this form, this is a fully aquatic, this is a genuine whale, is very short. That's not a lot of time in terms of mammalian evolution to do a lot of engineering.
So 8 million years for random mutations at the DNA level to end up from that mouse-looking thing to that...
to get you over here.
Yes.
8 million years might seem like a long time, but when you look at what has to be changed to go from here to here, it's not a lot of time at all. And here's why this is a problem for evolution. You've got to modify a lot of features starting basically with chance events. Random mutations in DNA. Those are going to affect development, that is how the animal is built, and that will then change anatomy and function. And it turns out that when you look at evolutionary theory itself, what it's required to go from here to here in a way that is viable, that actually works, you can run out of time overnight.
Well, let's hold that thought right there, Paul. We're going to take a break. You're going to want to stay with us. We're going to talk about how much time, according to evolutionists, it takes to turn a land animal into a sea creature. Stay with us. Welcome back to Origins. We're talking to Dr. Paul Nelson, who's been sharing some fascinating things about design in marine life. Paul, we left with the question of time. How much time does it take?
All right, let me give you some details. According to standard theory, everything starts with mutations in DNA. Now, those are going to be filtered by natural selection, but we've got to have the mutations, and it takes a while for them to occur. So here in my little schematic, That cell has a mutation, all right? And time is running this way, and that one turns out to be advantageous. It allows for reproduction. In fact, it's favored. So it ends up dominating the population.
So this mutation is something that the cell's not supposed to do ordinarily?
No, it's a mistake.
Okay.
It's an error. Could happen in DNA processing or somewhere along the way. But in any case, it goes from here to there and ends up dominating the population. But if you look at what has to be explained, lots of mutations are required. Not just one, not just two. In many cases, multiple changes have to occur simultaneously to bring about a new structure or a new function.
And these changes have to improve or serve some advantage, right?
That's exactly right. They've got to enable the species to be better at what it does, a more successful competitor, ultimately paying off in terms of greater reproductive output. Having more kids than your competitors. So that's got to be solved. And then if we're going to go from here over to here, we can describe that mathematically. In fact, the equations of population genetics describe what's required over time to get from a starting population to the new endpoint that we want to explain. Now, the problem is, to build the new traits that you see in whales, you would require a large number of mutations, not just a few, because everything's going to have to be modified. And the reason that's problematic is we have a numbers game. It's got three basic factors. We need enough mutations for significant change to occur. So we're going to need a lot of generations because mutations occur at a certain finite rate. And or we're going to need high mutation rates. If we don't have enough generations, we're going to need to have a lot of mutations very quickly. That's hard on organisms. And or we're going to need big populations just to accumulate enough mutations. Now, this is problematic, all of this, for mammalian populations because whales and their putative evolutionary ancestors, they don't have large populations. They don't have high mutation rates. And the gestation time for a whale is long. It takes a long time to build a new whale. So you put all the numbers together. Furthermore, you've got to go from one mutation, one lucky event, random event, to that mutation being present in all the members of the population. This is known as fixation. You start with one, you've got to go to everybody. Again, that takes time. So let's say we're going to build this, all right? This is a novel system, wasn't present in the ancestors as far as we know of the whales and dolphins. It's essential for them to make a go of it. They've got to have that functioning cooling system. This is where we end up. I don't go into casinos. I don't know about you. You don't either, and there's a good reason for that.
Well, they're designed to take your money.
They're
odds
designed
are
to
against
take your
you.
money. That's right. But the odds are against you. And in the evolutionary casino, you've got to win all the time if you're going to bring about successful change. So move the testes inside. We've got to redirect blood flow. We've got to add new blood vessels. We've got to change mating behavior. We've got to modify other anatomy. You're going to be sitting there looking at that window for a long time, hoping it comes up a winner, and you get the evolutionary payoff. All right. Why don't I go into casinos? Because the odds are against me, right? I go in with $1,000. I sit down at the slot machine. Eventually, won't take long, the casino will have all my money and I won't have any. So, why is this a problem for this system? It has to be coordinated. If you move the testes inside, but you don't cool it, you're not going to have production of normal sperm. Sterility will follow. Bad news for any species.
That creature's going to die
without
any young.
But, right, why move it inside unless you can cool it, but why cool it unless it's already inside? So these two changes have to be coordinated in space and time to bring about normal function. That's a problem because here's where we are. We are counting on chance to do this for us. And chance and randomness are really the enemy of function. No one gets on an airplane, sits down, and wants to hear the pilot say, "Ladies and gentlemen, there have been 20 random changes to this plane, but you know what? We're going to take off anyway."
I don't think I would.
So let's suppose we're successful here, 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 and here, but we don't modify mating behavior. We've got one more window that's got to come up right on that slot machine. The reason this is problematic is when you do the calculations, there's a major timing problem. Just to get 2 coordinated mutations, 2, and it took a lot more than that to build that system. 2 scientists at Cornell said, for humans, it would take 216 million years to get just 2 coordinated mutations. If you apply that, that's the chimps and humans, apply that to whales, the number ends up being over 43 million years.
But we only have 8 million years to do it.
We don't have nearly enough time. We are simply going to run out of time. This is the paper from these 2 guys, 2 scientists at Cornell. It's going to take a long time indeed if you're counting on chance to do the job for you. So, bottom line, it's a bad bet in the evolutionary casino. You don't have enough generations, the number and types of mutations are prohibitive, and mammals just don't have big enough breeding population. It's a problem. Ray, I work with Illustra Media. This is a film production company that focuses on intelligent design and the evidence from biology pointing to a supreme intellect behind living things. The clip we're going to look at is from one of their films.
The animal's distinctive clicks are critical to its survival. For a dolphin's world is often one of limited visibility. An immediate recognition of food, allies, or enemies hinges upon sensory mechanisms other than vision.
You can't see very far underwater, but sound travels 4 times faster underwater than it does on land. So they're able to use sound to see.
Echolocation, or biosonar, is a complex biological system. Dolphins use it much like a submarine relies on sonar technology to navigate through environments where visibility is marginal or non-existent. In basic terms, a dolphin's echolocation works like this. The animal produces a series of low and high frequency sounds that are transmitted through its forehead. After these sonic waves hit an object, echoes bounce back. The greater the distance, the longer the delay in their return. When the dolphin receives the reflected signals, it forms a mental image of the target's location, size, and speed. Echolocation requires several component parts, each designed for a specific function. When integrated, they form the most efficient sonar system on Earth, natural or man-made. Dolphins have no vocal cords, yet they produce a wide range of sounds. The process is pneumatically driven, controlled by the flow of air. How well does echolocation work? In control tests, a dolphin can determine the difference between a golf ball and a ping pong ball based solely on the density of each object. And on the seafloor, it can find small fish buried 3 to 6 inches below the sand.
A dolphin can find a BB at the bottom of a swimming pool, blindfolded. It can see inside of things. It's an amazing device, and if somebody had invented this and had it working as well as the dolphins, they'd make billions of dollars.
That kind of evidence that we find in Illustra Media, I think, points powerfully to an intelligent designer behind the miracles of biology.
I think that's the key. We're just looking at the evidence. We're not looking at religion. We're not looking at the Bible. We're just saying, what does this creature's cell and anatomy tell us? And we're going where it leads.
That's right. We're following the evidence where it leads.
was surprised that the skull wasn't more complete. I thought you had this full, because I've always seen the models in the museums of the full skull. How did you figure out what the shape of the skull? Was it based on these bones, or did you have other fossils to go from?
So the shape of the skull is based on the fossils that we have, and so we have the parts that have the eye and the brain case and the back of the snout. We don't have the tip of the snout, which is unfortunate because we don't know where the nasal opening was, therefore. However, we did find the whole lower jaw, so we do know how long that snout was. We don't have a sense for its exact shape. So that's based on related animals. Those related animals all have the nasal opening way in the front. So those related animals would be Cucucetus and Pakicetus. Those have their nasal opening way in the front, so it's likely that Ambulocetus had that too, but we don't know that.